Now entering the Bitcoin Podcast Network.
Welcome to Hashing It Out, a podcast where we talk to the tech innovators behind blockchain infrastructure and decentralized networks. We dive into the weeds to get at why and how people build this technology and the problems they face along the way. Come listen and learn from the best in the business so you can join their ranks.
Welcome to Hashing It Out. As always, it's me, Collin Couchet. I regret to inform you guys that Corey will not be joining us for this particular episode. He is tending to a family emergency, but we wish him the best, and I'll be continuing without him. Today, actually, we have a pretty good episode. We've been trying to get these guys on for a while. It's Michael Yuan from CyberMiles. Michael, tell me a little more about CyberMiles and what you guys are doing over there, so our audience has some background so I don't murder it.
Sure, yeah. Hi, Collin. So this is Michael Yuan from CyberMiles, and I'm the co-founder and chief scientist at CyberMiles. And so in short, what we want to do is to build an application-specific blockchain. And which application? It's the e-commerce application. So we want to build a public blockchain that is optimized for e-commerce applications. That's what we want to do.
Gotcha. So when you're looking at a blockchain specifically for e-commerce, how do you define e-commerce, and what is the actual scope of challenges that are specific to that field that you think you need to address with a unique blockchain?
Right. Yeah. So, I think people have been wanting to use blockchain for e-commerce since the beginning days of, Bitcoin. We all remember the guy who spent, I forgot, like 10,000 Bitcoins to get 2 pizzas, something like that. And then one of the earliest use case of Bitcoin is Silk Road, right? If we remember, it's a dark marketplace that it's very e-commerce. It's people use Bitcoin to buy and sell stuff.
Yeah, absolutely.
Right? That's so. I think using blockchain technology or use cryptocurrency for e-commerce type of applications. So how we define e-commerce is a marketplace that allows people to buy and sell physical goods or digital goods. So anything that can be sold or bought is e-commerce, and that's pretty much the underlying use case that people have been wanting to do since day one of cryptocurrency. However, if fast forward to today, we have not seen much success from it. We have seen some success from Silk Road, although it's illegal, so it's being shut down. And we have seen marketplaces like OpenBazaar who use Bitcoin as a payment method. And today, I think most people still use Craigslist or eBay. That's very few people actually use OpenBazaar. And if you look at, Bitcoin as payment method, a lot of companies has, regular e-commerce companies has tried to accept cryptocurrency on their website, right? There's, I think Overstock is one of the early pioneers. And then, there's companies like even Dell, or, very traditional, computer hardware company. And there's payment gateways for that. There's BitPay, and there's a bunch of companies like that, who enable traditional e-commerce to accept Bitcoin. But things like that has met with, I think, mixed success, or I would say not much success. Because, as we learned from the guys who spent like 10,000 Bitcoins to buy stuff, the primary purpose of Bitcoin is not be used as payment method, because the price fluctuates a lot, right? So if you look at those things, if you look at, if you're like me, if you have ever spent Bitcoin to buy stuff, you would always remember the day where the Bitcoin price doubled after you bought something, and you come to regret. How come I spent so much money to buy a chair or buy a book, something like that? You will never remember the days when Bitcoin price dropped after you bought something and, you got it for cheap, right? So from the consumer psychology or from personal psychology point of view, there's, the traditional cryptocurrency is not very good fit for e-commerce, although the demand is definitely there. So from our point of view is that, we are trying to build the whole infrastructure that address not only this problem, but also the problem with the winner takes all or the centralization of the e-commerce marketplace. We have tried to build this on Ethereum and was not successful because of the technical limitations that we're going to talk about later. And so that's, basically prompted us to build a new blockchain infrastructure that is based on Ethereum, is compatible with Ethereum, but with a lot of optimizations that are e-commerce specific.
Now that's okay. So that's where you ping my interest. All right. So I'm going to probably jump ahead a bit on this one, but you say you want to build a compatible Ethereum blockchain, meaning that it's running off of a fork of the Ethereum protocol. I take it, correct?
Yes.
Okay. So why did you go with your own blockchain and not a layer 2 kind of blockchain like a plasma chain?
Right. So Plasma solves the some of the payment issues, but it's for us there are two fundamental innovations that we made from Ethereum. So the protocol at the protocol layer, we try to stay compatible with Ethereum, but there are two things that we have done that's significantly different. The first is that we want to jump ahead and become delegated proof of stake, or at least proof of stake today. Because it's going to take a long time for Ethereum, for Casper to come along, and then Jasper, right? That's, it's for them to balance the interest between the mining community and the POS community is going to take, I think, at least a year and a half, or maybe even 2 years, right? But by building a new blockchain or building new infrastructure, we can just jump ahead and without all this baggage, right? Just do a dPoS chain from day one. That's what we want to do, right? That's the first thing. It's a consensus layer. We want to do, what Ethereum has always wanted to be doing. That is to build, 10-second confirmation and finality in each block so that you don't have ambiguity and much, much faster processing speed. And all the layer 2 network stuff can also be built on this network because this is Ethereum compatible, right? But with much faster mainnet. And the second thing we really want to do is actually the technical issues we want to do is to improve the Ethereum virtual machine. The EVM is a Turing complete virtual machine. It can perform any computing task that human beings can come up with, right? That's what Turing complete means. However, it is not optimized for any specific task. So there are a lot of things that are going to take so long to compute on Ethereum. It's not practical. So very good examples including, iterating over a large amount of data, a large array, for instance, or common public key encryption and decryption stuff. And those people have measured, how long it takes to do, PKI stuff on Ethereum. The conclusion has always been going to blow the whole block gas limit. So, even if an entire block does nothing but to execute a smart contract that encrypt using a public key, it would not be enough. So things like that, while theoretically possible on Ethereum, is not going to be practical. So however, in the e-commerce marketplace, that we want to build something that can address many number of e-commerce challenges, including buy and sell personal data. The data marketplace is one of the integral use cases that we want to address. And also the ability to bring another very interesting technical challenge that I didn't mention is to bring off-chain data onto the blockchain. For instance, you want to bring things like the delivery confirmation, or even the supply chain finance where people have paid their loans or not. Things like that where you want to integrate with the banking system. And with things like that, there are lots of encryption and decryption stuff that has to happen on the chain, including not only the public key stuff but also proxy encryption and other more weird and more interesting stuff, right? And for those type of work that we can, for those type of workload that we can provide C++ based extension to the Ethereum virtual machine. So a lot of those computation for us drops down to the native operating system level and can come back in, I wouldn't say milliseconds, but in a split second, right? Instead of doing it at the virtual machine level, which is going to take much longer. So so it's so basically we have built based on the Ethereum virtual machine, we have built our own virtual machine that's extended in a certain direction, right? Made it a lot more faster and a lot more capable, but also adding a lot of opcodes and keywords for very specific tasks. That's why we call it e-com, or it's a blockchain optimized for e-commerce. It's a virtual machine is built this way. It is going to be just as slow as Ethereum in most tasks, but for e-commerce related tasks, it can be a lot faster. Some of the performance tests that we have done is 100 times to 10,000 times faster. So it could be, 4 orders of magnitude faster because it's not performing those tasks in the virtual machine sandbox, but drops it to the native C++ layer. So that's if you would ask me what are the two engineering innovations that we have done, those are the two. So we build a dPoS, and then we build a new virtual machine. And
so you've covered a lot of things that just strike a particular chord with me. So scalability is just one problem in Ethereum in my mind. I do like the efforts that are being made, and I think there's some incredible stuff being done on the consensus mechanism side with was it Serenity, otherwise known as Shasper, otherwise known as Beacon Chain Ethereum on the layer 1 side, and some amazing efforts with the Plasma implementers and these general state channels to handle scaling. And I believe that those are all good general solutions that should apply if they work to pretty much everything that goes forward on most networks. Although I will say that I think that proof of stake might have an issue in that people need to build value before they implement proof of stake. Otherwise, it's kind of an issue for the early adopters that have too much power. So I'm interested in the consensus mechanism side of things that you're doing, but I think because of the radical nature of what you're doing with the virtual machine, I want to talk a little more about that first.
Sure. Yeah.
The Ethereum virtual machine was built specifically with certain intents in mind. One of them is that the execution of code is sandboxed, and there is a security around the fact that everything runs in the EVM. When you're talking about adding C extensions to your own custom VM, how do you prevent? First off, how do you make sure that everybody has the same extensions? And second off, how do you protect those calculations done on the operating system level?
Right. So that's for things like that to happen, we would have to make trade-offs. Right, that's also why I say Ethereum would probably never take the approach that we took, because it breaks certain philosophies that they hold dear. So let me explain what we did. Right, so in the end of the day, the EVM is written by cryptographers. Those are written by it is a very small VM, and it's not very optimized, but it's very tight, and it's designed to reach consensus. So it has no ambiguity. So for instance, there's no two ways to come up with the same answer, or two codes or a piece of code on different machines would not produce different results. That's characteristics of the EVM. But the EVM also shows its limitations. Like I just said, there's from our point of view, if you want to build a data marketplace or things related to e-commerce, it's really hard to do it with smart contracts on EVM. So I think even Ethereum community has realized that, and we are also actively participating in that. Is the next generation of virtual machines, EVASM, right? EVASM is Ethereum flavored WebAssembly, and WebAssembly is a much more versatile virtual machine. It supports, I think, all the languages LLVM supports, which I think there's maybe 20 of those languages, including C++, right? And the Ethereum flavored means it separates out the consensus computation and the general computation. So the consensus computation is still being sandboxed and then being being put on chain, and then much of the general computation is done on the node that you connect to, and it may not get on chain. So there's a complex design with the EVASM that separates out the consensus computation and the general computation. So that's also the kind of direction that we want to go. But because we are modifying off EVMs, so we are taking a less strict or less mathematical approach than they do, because EVASM, to be frank, I think it's still at least 2 years away. It's because it has Casper and Jasper has to be done first, and then because the virtual machine is tied with the consensus mechanism, so it's a long way to get there. But for the EVM extension that we did, we are just using C++. So to answer your question, there are two questions that you have just raised. The first is, how do you make sure that everyone has the same extension? There's a mechanism on our blockchain, because our blockchain is POS, is in fact dedicated proof of stake. So there's a voting mechanism for people to propose what C++ extension that they want to put on the blockchain. And then for the super nodes, or for the other nodes, or for the what we call validator nodes, to evaluate those. And we have tools for them to evaluate those and to step out randomness and things like that. And then determine if those extensions can be put on chain. And if 2/3 majority of the validator nodes vote yes, then this extension is being put on chain and put onto every node on the network. So so it's like I said, this some people may consider it's less than optimal, because now you have a committee deciding which which software extension can be put on chain. But to compare it what has been done today, if you look at Ethereum, there's notion of native contracts and precompiled contracts, and those are built into the software itself. The update cycle of those software is basically Ethereum software itself, and it being determined by a small group of core developers. And here, it's also being determined by, I would say, a relatively small group of core validators. But at least to say those validators are provide the governance of the blockchain. So I would, of course, this is based on where I sit, right? But for me, it's probably more preferable to have the validators determine what new functionalities goes on the blockchain, rather than core developers who basically do not answer to the community. But people can argue about this all the time. That's but that's the beauty of it, right? We got to try different governance mechanisms. So for us, we can update the blockchain without forking or stopping or changing the software. Even changing the software, we can adding software to the blockchain this way. So we compared this to replacing the engine where the airplane is still flying, right? That's because if the passengers vote to say that we need a new engine, that we can put on a new engine. So that's how we make sure that everyone has the same set of extensions. And then those extensions themselves, we also only support a limited number of operating systems. So we, unlike Ethereum that supports a large variety of different operating systems out there, the CyberMiles blockchain as of today only have node software for a small number of Linux distributions. That's our limitation. But that's we hope to improve this in the future, right, by building out new tools and building out for new platforms. But as of today, we only support a couple flavors of Linux. We are not like Ethereum that support a large diversity of operating systems out there. So those, I don't know if that answers your two questions.
Well, do you? It does. So how? See, I have so many questions that it's very difficult to choose which ones to jump in with. I guess we'll have to talk about. We'll start with the proof of stake, delegated proof of stake. Explain. So we've actually never had anybody on the show with delegated proof of stake as their core consensus protocol. And my knowledge of delegated proof of stake isn't quite as strong. But I did remember reading, I think it was called BitShares, and I remember reading some articles on it about a year ago, I want to say, And they have I think a delegated proof of stake consensus mechanism. And what I saw was that they were dealing with issues of or questions of not necessarily issues, but questions of centralization. And it sounds like you are aware of those issues and don't consider them a particular concern. So, for the benefit of our audience and myself, can you go over delegated proof of stake in your system, how it works, why you chose it, and address some of the concerns about keeping the network trustless?
Right. Yeah. We'd love to do that. So from our point of view, I think that's I think this is probably the consensus. What is dedicated proof of stake? Dedicated proof of stake is a direct imitation of a human political system that is called representative democracy with land suffrage. What does that mean? It means people who own land can elect Congress, and then the country is governed by the Congress they elected. Okay, so it is not one person per vote. It is your vote depends on how much land you own, but still, the voters do not govern the country directly. Or govern the society directly. It's a representative, the Congress that they elect. I think this is this is a political system that Rome has adopted, and it's also the early political system in America. Before there's one person, one vote, right? So there's a large amount of precedents of why this is the case, and why this is might be interesting for blockchain, because if unlike the human political system, if when a person votes, there's really no consequence for him individually, right? So you see people voting, that's I wouldn't say irresponsibly, but that's they can vote however they want. But in a political system where there's land suffrage, there's because you have to put your land or your property online. So if you vote wrong, the properties that you put online could be slashed. So this slashing mechanism, I think, is critical for any POS system. Now, the dPoS system and POS system are, I think it's provide different level of centralization. If you have truly a POS system that everyone can vote and everyone can govern, then then you may argue this provides the best decentralization. However, in a dPoS system where you elect your representative to govern the system for you, then by definition you have a level of centralization because the elected representatives are centralized. It's like just a centralized government. However, in the extreme where everyone is elected representative, so if you elect a large number of elected representatives, then you are sufficiently decentralized, right? That's if the number of representatives is the same as the number of voters, then you are POS. You are exactly like POS. However, if you are only electing one representative, the king or the dictator, then you are very centralized. So for us, dPoS and the POS, the centralization debate is a matter of degree. It's how decentralized I can make my dPoS, right?
Well, the thing with POS is that anybody with the proper amount of stake can decide to be a validator and check the network, and that means that anybody can basically say, "I want to make sure that Ethereum's honest," and they can detect problems themselves. With delegated proof of stake, it's about the number of people. From what I understand, it's the amount of currency someone has is somehow tied to their voting power. Because you can't. I mean, in theory, what you could do is just take your all your currency and have a minimum vote amount on several nodes that you run, and then you've just increased the number of votes you have. So it's really useless to try and cap that. And what you do instead is you do a vote power proportional to currency owned. Is that correct? Am I understanding that right?
Right. So there are two levels, right? One is how much currencies that you have, and the other is how much currencies other people are going to vote for you. So different people have different dPoS systems set up, right? in our system, it's a lot like our political system. So the Congress person can be poor. He can have no money. But if people who have money want to stake him, they can elect him into Congress. You know what I mean? So it's a matter of campaigning for the community, so that the people, the token holders themselves, may not necessarily want to be a validator or a delegate, right? They can just elect someone to act on their behalf.
So that brings up a question that I have is, what would it take to own the network from a currency standpoint? So let's say, how much currency would somebody have to own? How much voting power would someone have to control in order to sway the network in their favor?
Right. So there are actually two questions. Well, actually, this is a complicated question. I provide three answers. Okay, so that's not too much. So the first is, whether if someone controls a large amount of currency, or someone controls a large amount of voting power, can he cheat on the network? Basically screw the network to his favor. And yes, that's also one of the things that we repeatedly see, which I won't name names, are certain projects that has dPoS, but the foundation controls 90% of the token supply. Then it's essentially the foundation going to do whatever they want, right? Because they have all the voting power essentially, and that's but that's also the case. That's also not the case for a lot of those for a lot of the dPoS networks. For instance, for us, the foundation controls less than 10% of the outstanding coins, right? So there's no major players that has so much voting power that are going to screw it, right? So that's the first answer. And the second answer is in the protocol. So different people have different mechanism to prevent the aggregation of votes and to prevent bad behaviors that are going to happen on the network. So in our protocol, that we have a cap of 12% vote. So when you have voting power, you get benefit from the network, in the form of, I'd say, the network has certain inflation built in. So if you are a validator, you can get part of the inflation as benefit, right? So that's, essentially how most of the dPoS networks set up. And we have a cap of 12%. So if you go over 12%, you get no additional benefits. So in that case, the economic incentive goes strongly against people who staking you over 12%. So if I'm a large token holder and you are a politician and wants to be a validator node, and you already attract 12% of the community's votes, there's no reason for me to stake you anymore, because the token I staking you would not get any benefit, right? So because it would not earn any additional inflation. So I would choose to stake someone else who have a smaller stake.
But in economics, so this is not the same as elected officials, where they get one vote type of deal, because technically, let's just say some Bitcoin whale says, I'm going to own the CyberMiles network. Okay. I'm going to buy, let's just say over 50% of the currency. It's probably more like 2/3 is what you'd need. But considering that the currency is probably valued kind of low at the moment, because, it's new. Then they would go, that there would be something they could just totally do, is they could go, I'm going to buy, a significant portion of the currency, or me and my friends are going to buy a significant portion of the currency. And these kind of people also have major compute power at their fingertips. So how do you stop a whale from throwing up, let's just say 5 voters, 5 delegates to represent the network out of like, let's just say 9. Okay. And so now they control a majority vote, even though, just by virtue of their currency, and they're also staking in their own votes. So they have each one of the 12%. So they'll control 60% of the vote. How do you stop that kind of thing from happening? Because in the marketplace, we have regulation. And so this is not a pure, like, government model in that a government person, a congressman can only go and have one yay or nay. This is a proportional model where certain congressmen have more weight. And it doesn't sound like there's a strong cap on the number of congressmen available. So I could spread out my currency and throw up my own delegates. But furthermore, my friends who are aligned in my interests can do the same. And what we would have is sort of a trust situation. We have antitrust laws in. So I'm speaking of business trust. We have antitrust laws in our system to stop certain industries from talking to each other. For instance, if you want to speak with the CEOs of the tier one wireless carriers, they can't be in the same room without the SEC being present. So what can you do to prevent somebody from creating a sort of brain or economic trust from manipulating your network?
Right. So that's I think what you have just described, the Sybil attack, or you can have that's people team together to try to control the network. People team together to control a country as well. So is there a mathematical way that we can prevent this to happening? No, there's not. So, but there are very good solutions. However, why? Because although the validator nodes propose the blocks and build the block and produce the blocks, all the work that they have done is out there in the open, right? So people can, all the other nodes, 4 nodes on the network, they are not validators, and they do not get paid from the inflation. They can still see and check and independently check what the validators has done. So if the validators decide to cheat, they add their own illegal transactions into the system. So, for instance, transferring money without the private key and things like that, without proper signature. Can they do it? If they control the voting power, yes, they can do it. But once they do it, everybody else on the outside would be able to see it, and the network would lose public trust at that point, and then all the coins goes to zero. Because
so
if the network
social factors to sort of keep the network honest, rather than purely economic factors. So I could see where that might work in practice. I could also see where somebody could obfuscate that information in practice, meaning that it's not them, but it's their cousin's best friend, or it's somebody who owes them a bunch of money. Well, you'll be the validator for this network, blah, blah, blah. Well, we're going to take all the shares out. You're going to have to run the hardware, and that's okay. I could see a lot of ways that people can, in the real world, like manipulate the system so that people don't even know it's the same person. How do you detect that as a user on the network?
Well, yeah, that's I think the check I just described does not depend on whether I know whether those validators are the same person or related by blood or by some financial interest. Is that if they want to screw the network, they have to do something illegal, meaning they have to do something mathematically illegal, right? They would have to transfer money out of account without a signature. And this can be done by them because they have the voting power to do it. They say this is a legitimate transaction and has to be included in the block. They can do that. However, once they do that, everybody else on the network also sees it.
Yeah,
and
but
then,
that's the underlying problem. The Byzantine, the general problem is really a problem of ordering of transactions more than it is anything else. Meaning that you can order transactions in your favor and not do anything illegal, and still the network wouldn't know any better, because the whole purpose of the validators is to choose an order and elect a leader to choose that order of the transactions and how they're processed. So they don't have to necessarily do anything illegal to also still game the network.
Well, I guess we're describing different levels of attacks, right? So there's I'd say the most severe type of attack is to issue money for yourself, right? That would be really illegal. But if we are talking about other more subtle things, I think one of the things that's to have an open, transparent network is that everything in the network can be seen by everybody else on the network. The things that validator did, like you said, is to make it official, is to say this is the way that we think this should be done, right? This is our consensus, because there's X number of validators, and 2/3 of them said, we computed this and had the same results. Especially for smart contracts and things like that. But everyone else on the outside can also compute themselves. And it's although there's no mechanism in the network for you to dispute the results from the validators say it's final. However, in the larger social context, you can always say those validators start to cheat, and for different reasons. Maybe they have financial interest, or maybe they've just been bribed, right? Maybe there's some when you talk about Bitcoin whales, they do not even have to buy those coins. They can just promise to bribe the validators, right? How do you prevent something like that, right? They would have to do something that the community disagree. If sufficient people on the outside community disagree with what the validator did, then I think the network would lose value. And the network lose value, there's a direct consequence to the validators, because the validators hold most of the coins. Right, they are at the most financial interested not to see this happen. So, but what I'm describing is a social experiment. It's when we look at Bitcoin 10 years ago, we did not know that people are gonna join mining instead of attacking it, because there's equal chance people might make money from 51% attack than mining, right? But turns out mining is safe, or at least up until now, as far as we know, Bitcoin mining is safe. I think for POS or dPoS to move forward, there could be a lot of experimentations and things like that. That's we are one of the systems that we are trying to build that we think has a good chance of being safe, right? But is it perfectly safe? I can never guarantee that. Like you said, there's 100 times that you can think, that people might attack it. But then I say people won't attack it because they're going to lose money. And you say, the money they lose is not going to be the money that they get. I think that's why we need more blockchains than Ethereum. We need more, a situation where you have a lot of blockchains, that a lot of experimentations, and they can exchange in some format. But that may be a discussion for another day. But that's
let's discuss it now, because we a lot of our audience are in this space trying to build on Ethereum and are also trying to build alternatives. So I see your point about how Ethereum doesn't quite fit the market. It doesn't have a niche fit, both with the current state of the consensus mechanism and the EVM. Why not just build your system as a plasma chain, though? I still don't see a solid. I see a need for a layer 2 solution like yours, but my question is, why not back it with something that's trustless, meaning that people have an exit strategy in the event that they find something wrong. So they don't want to devalue it because it's being backed by something super strong like Ethereum. Current early implementations of Plasma are available, and that they'll probably be rounded out sooner rather than later. I think there's been some articles on CoinDesk saying that Plasma is dead, but I will guarantee you that's not the case. Plasma is very much alive. It's actually thriving. They're doing some really cool stuff with Plasma Cash and just regular Plasma contracts. There's very interesting ways of staking into separate chains. Why not join that effort and make CyberMiles a high throughput dPoS backed ERC20 or ERC whatever token to enable the trustless mechanism that Ethereum has to back the CyberMiles protocol, and also maybe enable other people to fork your stuff and put up their own sort of CyberMiles variant.
Yeah, that's actually something that we're actively looking into, because we're open source, right? So if someone want to use our software and build a sidechain on Ethereum, that they can definitely do that. However, I would also say, that's the Plasma is really, really new. I think Plasma MVP just came out like a couple months ago, and there's lots of issues, unresolved issues. And as far as I know, there's no less than 4 or 5, competing Plasma implementations, each addressing a different problem. Although I saw Carl's talk on DevCon 4, I was in the room, and that's his notion is that there's we have finally done the long climb. We're at the top of the hill, and we can see the sunrise. As much as I want to believe that, I think it's probably very optimistic, because and we are also addressing some of the most easiest use cases for Plasma. As of right now, some EVM, there's no virtual machine customization. There are lots of things that I think Plasma has a way to go. And also, I would also like to point out what we have done is actually sharding. A Plasma is a side chain, but sharding is another way to increase Ethereum throughput, right? That's what we have done is what we call logical sharding, because if there's Ethereum compatible blockchains for each particular application verticals, then you can shard your workload this way, because games going to be on blockchain A, e-commerce on blockchain B, finance on block C, IoT on blockchain 4. That's you can actually shard your workload like this, as long as there's a way for those blockchains to exchange tokens. And because they're all Ethereum compatible, it might be possible to connect it to the beacon chain like this way, right? So I think there are lots of interesting and unresolved issues, but we can't wait. We can't. Our project started 12 months ago, when Plasma doesn't exist, back then, not even an idea, right? We can't wait for Plasma to be fully maturized and then build our stuff on top of it, right? But we are an open source project that we are actually, exploring. Is it possible for our virtual machine to be run as a Plasma sidechain? So, what you have just discussed is very much on our mind as well. How do we play with the ecosystem that the larger community has built, right? How do we play in the sharding? How do we play in Plasma? But it's but we need to see something, and we can't sit here and just wait, right? That's we used to have a ERC20 token and just have it traded on exchange. That's not what we want to do. We want to be actively building stuff, even if it means that we have to build it ourselves and maybe consider integrating later.
I completely agree with that approach. It's a business answer. It makes perfect sense to me. Build your own thing, and when the time comes that the technology matures and you can integrate, be open to the idea. That's all I really need to know, is because there's a lot of side projects out there where people are doing their own thing, and I feel like there's got to be. I have a personal philosophy. There will be one blockchain to rule them all. There has to be. There has to be one single source of truth. We cannot have a mishmash of different truth mechanisms out there, because one will eventually be the category king. One will eventually be just the de facto standard. And it's just an evolutionary process. It takes time. It takes maturity of the technology. It takes adoption, and all these things are slowly happening and slowly coming together. But I agree, if you need to build something to be ready for that moment, do it now. Just go for it. So I totally get that. And also, I want to go back to the virtual machine stuff. So we could talk about dPoS and its kind of controversial flaws all day, but I think that's been, to use the episode, the podcast title, hashed out quite a bit already elsewhere. I think that dPoS sounds like a wise choice for your needs right now, and I do think that it would actually be more interesting when it's integrated with like an Ethereum blockchain. But the thing that's really the most interesting to me is still the virtual machine that you've got going on. So you've mentioned that the virtual machine was built by a bunch of cryptographers with cryptography in mind. And because of that, it's had a lot of flaws, I want to say. Not flaws is not the right word. Let's just say hard-lined features that I particularly find difficult to deal with. One of them being that register sizes in the virtual machine are fixed at 256 bits, which is a large space. And also it means that anytime you want to store anything, you're consuming 256 bits right there off the bat, which means that any sort of storage onto chain, if you want to store a single character to flag something, that's 256 bits, right? That should be 7 bits, but no, it's 256 bits. Things like that. The lack of SCP, encryption functionality in such an encryption-oriented system seems peculiar to me. In that I'd like to do some elliptical curve work inside my virtual machine, but I can't. So, that's interesting to me. And another one is I don't really need Turing completeness. I need verification. I need formal verification in a lot of my contracts. So why would I need a full Turing complete system, which can't be formally verified, when all I need for I'd say a solid 98 to 99% of all contracts out there just need basic non-Turing complete procedural kind of almost like database procedures kind of work. What is your virtual machine doing with regard to any of that, if anything? And what is the design philosophy around your opcodes and your virtual machine design?
Right. So yeah, that's I'm glad you brought it up. So there's for the EVM, there's we can make fundamental changes and then we can make application level changes. For the things like the size of the fundamental data structure, we tend to not to make those changes for now because that breaks compatibility. We want Solidity applications and Solidity bytecode to be able to run our virtual machine without change. So we left most of the things there. However, we made some fundamental changes. So for instance, when you talk about Turing complete, one of the issues that's I think I would even say the majority of smart contract issues are integer overflow. Is that when people explore because there's truffle has a safe mass library, and sometimes people don't use it, and then that creates opportunity for hackers to to intentionally call those contracts and add or multiply very large numbers and overflow those numbers, and the overflow is an interesting feature that's part of the Turing complete, right? Because people can always argue maybe the programmers intended to overflow. It's some kind of feature. However, we say like 99.9999% of the time it's a bug. That's so we would rather shut down that feature. So in terms of opcode, we introduced a new opcode, a new data type called safe integer. At safe integer level in the virtual machine, so automatically wrapped around by the safe mass library. And also even if without the safe mass, if the virtual machine detects overflow, it aborts the execution. The execution just fails. It would not overflow and pretend the program is still running correctly. So I'm just giving you an example of the fundamental data types that we are trying to modify their behavior or change their things. Although you could say that's by not allowing integer overflow, that we are breaking compatibility with Ethereum, because some applications that will behave certain ways on Ethereum would not behave the same way on our virtual machine. But that's a risk we want to take, because we think this behavior change 99.9999 times is a bug that we have to fix. Right?
Well, do you make it an explicit type, like a safe int type or a safe uint type, or do you go ahead and just make all uints safe math?
We did both. So it's we have a safe integer type that's if you declare that type and use that type, it's it's all operation around it is being wrapped in safe mass. But we also have at the virtual machine level, at the runtime level, we monitor those uints, and if the uint 256 overflows, the virtual machine stops and throw error.
Yeah. So the question I was going to ask is if the uint on the virtual machine overflows on something that isn't declared safe, then it would still be compatible because that's just how Solidity is. But if you only did it for the safe version, then that would also if you did it for the safe version and the regular version, it almost seems like there's no point in having the safe version.
Yeah, well, there are still some subtle difference. That's I probably wouldn't get into here. But you're right. It's if the safe version is safe and the regular version is unsafe, then we can still claim compatibility. We can do it that way. But there's so many existing contracts out there that are unsafe that using regular version, right? That's we thought it might be better just to fix them as well. So that's a choice that we make. As you know, all those choices are hard because they all have trade-offs.
Definitely. And compatibility is a difficult thing to stick to. Stick to your guns on that. So, what about having basic encryption functions? Would that be relegated to the C extensions?
Yes. So that idea comes from the early Java days. That's if you're like an old guy like me, that's I've done Java for many years, that we all know the JNI, the Java native interface, because original Java was very sandboxed. So if you want to access anything, like a device driver, like the sound card or the video card or whatever, that you need a device driver that's written for Java, that's JNI. But that's, so we have something called the libENI, that we have a special opcode that can, that can wrap around C++ applications in it. So we have, RSA encryption, that's a basic PKI encryptions, and all that stuff written in C++ that can be directly called from the virtual machine. By the way, this is not really a new approach. This is exactly what Ethereum does with their native contracts. But like I said, the difference between this and native contract is this can be added at any time by a vote. But the native contracts will have to be done by software upgrade circles, right? So there's lots of those things are not. I wouldn't say they are radically different technology, or they are that we are so smart that other people haven't thought about it. It's not. People have thought about it. We just took a different approach, right? That's and then there's one other thing I want to talk about on the virtual machine is. At the language level, we have integration with dPoS. What does that mean? It means, because one of the key use cases in e-commerce is that we need oracles. We need to bring off-chain data on-chain. So for instance, like delivery confirmation, bank accounts, things of that nature, right? Where the physical product is being sold or being received, things like that. I wouldn't say in the old world or in the world of Ethereum, the Oracle is a very difficult problem. That's you would have to provide centralized trust, or you would play some kind of crypto-economic games. Even alarm clock on Ethereum is very hard. That you would have a community of people who would be incentivized by some kind of incentive mechanism that would send certain signal to the blockchain at a certain time. There's project called Ethereum Alarm Clock, right? So for on regular Ethereum, the cost of having oracles, I think, is very high. But for us, that we have at the virtual machine level, we have in a regular Solidity, you can specify some function as owner only. That's only the owner of the contract can operate on those. We have a new keyword called validator only, meaning the only current validators can operate on those contracts, and then we plan to extend it so that only the majority of the validators can vote to perform certain functions. That allows us to bring off-chain data on-chain through validators, because if we made an assumption that the validators provide governance and they are trustworthy, because if they are not trustworthy, then none of the stuff on the blockchain is trustworthy, right? So
Right.
if we assume, if we assume those are good guys, then we can rely on them to bring real world information like FedEx receipts and things like that. They can provide the service to the blockchain by feeding this data into the smart contract. Essentially, the validators can act as natural oracles in this case. So that's also one of the things that we did for e-commerce. Then I understand this can be argued both ways. It can be good or bad. That you are too centralized. That's the decision that we made. That's the approach we took at this moment. Yeah.
And it makes sense. We went through that kind of. It makes sense why you went with this approach. And I think it's really great because you want to iterate fast over your machine as well. Meaning that it seems to me like the dPoS is almost a mechanism for driving innovation with your group. Meaning that if you want to add more functionality to your system, dPoS is a lot easier to get that done with than just regular proof of work, and proof of stake isn't really out there yet. I think that makes perfect sense to me. The question I have now is what do the tools look like for this chain? Meaning that wallets, mining validator nodes, just regular client nodes. Since you're trying to get your confirmation times down, you said below 10 seconds, that could increase the size of the blockchain significantly. Do you have a light client? What does the tooling look like for the end user?
Right. So we don't have a light client right now. It's just there's a lot of development effort. However, we have a pretty because we are Ethereum compatible, so we are standing on the shoulders of giants, I would say, right? So we can fork a lot of the open source projects, and we did, by adopting existing open source project for our needs. So, for instance, we have a new programming language that's based on Solidity. So we modified the Solidity compiler, and we call the language Liddy. It's just we thought it more liquid than solid, right? So we have Liddy C that can compile it, and then we integrated that into Remix. So we have our own fork of Remix, the web-based IDE for Solidity, and then we have our own forked version of MetaMask. So that tool set is complete, so you can have a MetaMask on CyberMiles and a Remix on CyberMiles, have them work together to deploy a contract and execute a contract written in the language that we provide, meaning Solidity and its extension.
That's awesome. And is it compatible with like existing libraries like Web3 or Ethereum JS?
Right. Yes, on Ethereum JS, for the Ethereum functions, yes. So for Web3, we have a Web3 CMT because we added a lot of functions and transaction types to the blockchain. So all the Ethereum transaction types we already support. But for dPoS related stuff, for instance, how do you elect the delegator? How do you, how do you elect the validator? How do you declare? How do you slash? Things like that. There's a large number of transactions that we added to that library. So we call it Web3 CMT.js. So it's very unimaginative name. Those are terrible names. But all those projects trace their lineage to various parts of Ethereum, right? We took those. We fork them, and then we make it work on our blockchain, and then we try to find a way to contribute back, for the Ethereum project, right? So we're talking about Web3, Remix, MetaMask, and then we have our own RPC services. It's sort of like an Infera, that's those service providers on Ethereum. And then we have, for the consumers, we have a mobile wallet called the CMT wallet, where it works with our mainnet, and it lists the CMT, which is a symbol of our token, and also the tokens that issued on our blockchain. It also has a naming service. It's a little like ENS, but it's for the token names, right? And for that wallet, there is a SDK that you can develop dApps that directly make. It's sort of like MetaMask integration on the browser side, but this is on the inside of the mobile app. you can develop dApps that lets the wallet pay for your gas and things like that. So you can write nice HTML app directly inside the wallet. So there's the point I'm trying to make is there's a variety of different tools that people are already familiar with, and they can just I think the learning curve is not very hard, so because all the Ethereum stuff can run on CyberMiles. And then you can explore the things that we added.
And what I love about that is that, okay, you're a fork of Ethereum. You're using existing tools which people are already familiar with. Mm-hmm. You're experimenting with new consensus mechanisms. You're experimenting with extending the functionality of the virtual machine. I really see CyberMiles as being a very interesting project for extending the capabilities of the Ethereum network, because a lot of what you're doing could technically apply to Ethereum if it works, right? They could look at what you're doing and go, that's amazing. We're going to adopt this into the main net. They've done it before. It's not something uncommon. I mean, was it Zcash had the ZK Snarks algorithm? They went, oh, that's a good idea, and went ahead and dropped it into the Ethereum the Ethereum virtual machine. So like, there's a lot of features that you're experimenting with because you have the freedom to do that. And I know that you're trying to build a network that's standalone. But again, like, I feel like there's going to be one category king ultimately. And I really do like the research you're doing because it's going to contribute to the entire ecosystem. And because you're basing your work off of Ethereum, you've basically become an R&D branch of Ethereum. So I really hope a lot of people hear this and decide to contribute to your project to get some of the features that they think are interesting onto your project, and in doing so can demonstrate with a lower barrier to entry what it would take to do that on the mainnet and what that would look like and what works and what doesn't work. But on the other hand, I also know that you have a business that the business model surrounding this where you want your chain to be successful. So I really do hope that you can integrate with other Ethereum networks as well, because I do see that being kind of the next phase of the evolution is going to be layer 2.
Right.
Yeah.
So for us, if we ended up being the e-commerce shard of Ethereum, then our mission is accomplished, right? Because we want e-commerce applications to deploy on our chain, whether it's in the form of a side chain or in the form of shard. That's all fine with us. It's just that we have to start somewhere. We have to build we have to go our own. We have to put the first step, right? If the community comes to the consensus and says, that's the Ethereum beacon network going to be the trust provider and everybody else being a shard, that's perfect fine with us. That we want to be in part of that world, right? That's that's to echo what you said. That's we want to be the pioneer in that space, not to experimenting with a lot of stuff. Especially the things that related with e-commerce, and to bring those business onto the blockchain. And 3 years or 4 years from now, where how we play into the ecosystem, we hope that we would be an active and a good player in the Ethereum ecosystem. That's we have been doing open source for many years. I personally have been doing open source for many years. So that's the community is our biggest asset. We want to be successful together. That's what I want to say. Yeah.
Yeah. No, that's great. So how did the name come up? How did you name your product or your chain CyberMiles? Where'd that come from?
Right. So a lot of people, when they heard it, they thought it's an airline mileage program being on the blockchain. But it's not. It's because we have an e-commerce company called 5 Miles in Dallas. It is actually a fairly large consumer-to-consumer e-commerce company, and it's you can think of like Craigslist, but it's for local, so it's all in 5 miles, and it's actually one of the biggest merchandise that's being moved by that network, used cars. I think CyberMiles is one of the largest used car dealers in the United States at this moment. So it has, 15 million American users registered on the network. So but that's the route of that's our e-commerce route, 5 miles. It's everything being done in 5 miles, and we really want to build a decentralized C2C network from 5 miles. That's our original vision. But on the road there, we find that we really need to build our own infrastructure in order to go there. So we call the infrastructure CyberMiles. It's just the miles, not the same.
Makes sense.
So
look, I gotta say,
yeah.
I came in a little bit skeptical because it did sound like airline miles, and it did kind of sound like something like that. And I was like, well, what is this? What is this actually about? And then I also hear people building their own blockchain. I'm like, oh, another one. But the infrastructure and the technology behind what you're doing is so sound in the way that it's definitely amazing research that needs to be done. And I love the sandbox environment that CyberMiles provides for doing that. I really am enthusiastic about this project. I think you definitely dealt with me quite a bit. Because it just makes sense the way you're doing things. And I really do see that it could play a larger role down the line in the Ethereum ecosystem, as far as, the virtual machine research and eventually like integration of different consensus protocols into the main network, or just a lot of the stuff seems to make perfect sense to me and will contribute to the larger picture of what we're trying to build with these decentralized systems. So yeah, major kudos to you guys. This is not a small undertaking. Building something like this is a very ambitious project. So I'm kind of curious, actually, what's the size of your team? How are you guys doing so much work so quickly?
Well, yeah, that's as any good open source project, we don't have a very large team. We have maybe I think 12 developers who are working on this full time, and so that's maybe 6 of them working on the virtual machine, and 6 of them working on the blockchain. But then again, what I would say is that we stand on the shoulder of giants, because we benefit tremendously from other people's work in this community. So, for instance, we benefit tremendously from Tendermint. They provide the BFT consensus layer, and we build the dPoS on top of that. And we definitely benefit from a lot of work Ethereum have done, and also the people in the Ethereum community who have done a lot of the tooling, like the MetaMask, Remix, and all those works. That saved us tremendous amount of time. But that's what I consider the true spirit of open source, right? You build stuff, and what you wish is that other people can use that stuff. Other people can build on top of it, which I think we are good player in this. And that is a fact that we can experiment with a lot of those ideas with other people's software. I think testifies the power of the community in this space.
Yeah, no, I think it's great what you're doing. I'm impressed that so much work has been done in 12 months. Even though you're standing on the back of the giants, it's no small task to just take their code and make it work for a whole new system. So, mad kudos to you. Is there anything we should have asked, or anything you want to tell our audience before we wrap this up?
Well, I think that's pretty much it. I really appreciate your questions and comments. There's lots of work ahead of us, and we want to be part of the success. Like you said, when the technology is ready, we want to be there. We want to be the ones who have the most ready solutions out there, right? So that's what we're trying to do. Yeah.
So how can they find CyberMiles, and how can they find your repos, and how can they find you, Michael?
Right. So it's our website is cybermiles.io. It's cybermiles.io. And if you want to reach me through email, you can say michael@cybermiles.io. And all our developer documentation and GitHub repositories is just github.com/cybermiles. And all this stuff, all our code are open source. We have no closed source software. So everything is open source. Everything is out there in the open. And, to get on, to run a node on our mainnet, to become a validator, to do anything, just go to our website and go from there.
That's awesome. That's awesome. I love what you're doing. Keep it up. I hope to see more innovation coming out of your group. So, and as always, you can find me at Collin Cusce. That's CollinCusce on Twitter, and Corey, who is unfortunately unable to attend this interview, is at Corpetty. That's CorPetty on Twitter, and you can find us on hashingitout.stream. Thanks, Michael. It was really great learning about CyberMiles.
All right, thank you.